Okay, we talked about how to name ionic compounds. Now we're going to talk about how to name molecular compounds. Okay, molecular meaning the covalent ones. So covalent bonds where they're sharing their electrons, right? Those are just nonmetals. So we have two nonmetals in these kind of formulas, and we can't use ionic naming to do this because it wouldn't make any sense. These aren't ions. So for the naming of these, there's still going to be two names. The first name is just the name of the nonmetal. Okay, so whatever the first nonmetal is, whatever its name is on the periodic table, that's its name. You may have to add a prefix for how many there are if there's more than one, and I'll show you the prefixes in just a minute. The second name, the second nonmetal, is its name for the periodic table, but the ending has to be changed to IDE. You'll remember we did that also in some of the ionic names too. And then this name also needs a prefix for how many there are, including if there's just one. So the prefixes work like this. Right? So mono would stand for one of something. And then we would use the prefix di for two and tri for three, tetra, four, penta, hexa, hepta, octa, nona, deca. So those are the prefixes we use for how many there are. And the reason we have to use these prefixes, we didn't use these for ionic, is ionic had charges. When there were charges, you could figure out how many there were going to be because we used the crisscross method. But we don't do that for molecular compounds. We don't do that for covalent. Right? There's no charges to use, so how many there are isn't dependent on anything else. We have to let somebody know in the name how many there are. So, example of this: if you had the formula CO2. Okay, CO2 is two nonmetals, so we know that's molecular. C is carbon, and since there's just one carbon, I don't put mono in front of it. So I don't use mono on the first name. So if there's just one of the first element, I just say its name, carbon. The second element is oxygen. But notice I have to change the ending to "ide", so it's oxide. And there's two of them in this formula. Therefore, I have to put the prefix di in front of it, so it's dioxide. So that's why we call CO2 carbon dioxide. So another example. Right, N2O. So N is nitrogen. So remember, the first name is just its name. So it's just nitrogen. Except that there's a 2 next to the N. So that means there's two nitrogens. Anytime there's more than one, you have to put the prefix there. So it's dinitrogen. O is oxide, right? Because the second name always ends in "ide." So O would be called oxide. And there's just one of them. But even if the second nonmetal has only one of it, I have to put the prefix there. So I have to put mono in front of oxide. But notice the spelling here. Okay? The spelling is not monooxide, because that would be two O's here, right in a row. And then that would look funny, because then you'd want to pronounce it monoxide. That doesn't make any sense. So here's what we do. Here's the little trick to all of this. If the prefix ends in a vowel, and all of them do, and the name of that element begins with a vowel, then we drop the vowel on the end of the prefix so that we don't have two vowels in a row. Unless it's di or tri, because we don't drop i's. Because really, if you dropped an I off of di, you wouldn't have hardly anything left. You just have a D. It'd be hard to tell what that was supposed to mean. So we don't drop the i's off of di or tri, but we do drop the O off of mono or the A off of any of the other ones if it would have meant there was going to be two vowels in a row. Here's another example of that. If you had the formula P2O5, somebody said, what's the name for P2O5? Well, P is phosphorus. There's two of them, so it's diphosphorus. O is the second element, so I end it with ide, so that's oxide. And there's 5 of them, so that's penta. But notice, again, I did not put pentaoxide, because that would have been A, then O. So we dropped the A on the end of penta, and so it's just called pentoxide. Okay? So we have to do that. We have to drop the vowel on the end of the prefix if there was going to be two vowels in a row. Unless it's an I, like in dioxide. I kept the I, then the O. So that's the only time I leave the vowel is if it's an I. Okay? Now, there are a couple of exceptions to those rules. For instance, there are a couple of molecular compounds out there that have common names that we've used so much over the years that we do not use their true chemical names. Like water, okay? H2O is molecular. It is two nonmetals. If we were to use the rules that we just learned, I would call this dihydrogen monoxide, right? Dihydrogen monoxide is what I would call that. But nobody calls it that. Everybody calls it water. Even chemists call it water. So nobody calls it dihydrogen monoxide. In fact, if you were to put that down on a test, it would be marked wrong. Put water, okay? Only people that are trying to sound smart call it dihydrogen monoxide. The other common one that has its own name is NH3. NH3 is a substance known as ammonia. It's been around for a very long time. We always call it ammonia, so we do not call it by its true chemical name, which, again, if we were to use the rules we just learned, the N here would have been nitrogen. The H, since it's the second element, would have been called hydride. And there's three of them, so it would have been a nitrogen trihydride. No, we don't call it nitrogen trihydride. We call it ammonia. Again, if you were to call it nitrogen trihydride on a test, you'd get it marked wrong. It's called ammonia. So those are two you just need to stick in your brain and remember. And then the last little exception is if the compound has carbon and hydrogen in it. Carbon and hydrogen. Then generally we're going to follow a different set of rules for organic chemistry. Now, organic chemistry has a whole bunch of extra rules on how they do their naming. We're not going to cover those in any kind of detail right now. I'm going to give you a tiny little sliver of how it works, just so you are aware and you can name some really basic things. I'm going to show you a couple of examples here, and then I want to show you how this works. Okay. So, for the carbon-hydrogen kind of compounds, all these have carbons and hydrogens in them. We go by the number of carbons and what kind of bonds are in the structure. So, for instance, if you had just one carbon starts off its name with the prefix meth. 2 carbons would be eth, 3 carbons would be prop, 4 carbons would be bute. That's not but, that's bute. And then the ending to each of those depends on what kind of bonds are in that. Are they single bonds? Are they double bonds? Are they triple bonds? If they're single bonds, we end it with ane. If they're double bonds, we end it with ene. And if it's triple, then we call it ine. So this one has 1 carbon, meth, and it only has single bonds in it, ane, methane. This one has 2 carbons in it, eth, and it's all single bonds, so it's ane. But this is 2 carbons, but it has a double bond in it, so this is ethene. Okay? So this is how we work these. We just go by these prefixes for how many carbons there are, and then the ending is all about the number of bonds that there are. This is the only one that you will see on any test or anything that we do in this class, CH4. So really, if you just go ahead and memorize that CH4 is called methane, you don't necessarily have to memorize all these rules over here. But I just wanted to point it out how it was done. But this is the only one you're really going to see in here, because we do talk about this. CH4 methane, that is natural gas, right? That's the kind of gas that you use probably at your house, maybe for your stove or your furnace. It's the kind of gas that we would use in class with our gas jets and our Bunsen burners if we were in class doing that. Okay. So again, don't try to name this using the rules that we just learned. This is not called carbon tetrahydride. This is called methane. All right. So that takes care of all of the covalent naming.